Amazing job on your first lesson yesterday on multi-digit multiplication. By 3:30 yesterday, there were already at least 20 scholars who completed their independent practice. Amazing work. Today, we're going to continue our practice with multi-digit multiplication, and I have a special guest. Unfortunately, it is not Kitty Badger. She is currently taking a nap on her bed. It is our friends at Brain Pop. Moby and Anna are going to talk to us about arrays. Go ahead and get your popcorn ready and settle down.
How many muffins do we have for the bake sale? Wait, Moby. You don't have to count each muffin. That'll take a long time. You can use an array to help you count. What is an array? An array is a set that shows equal groups in rows and columns. I can organize these muffins into an array. I can group them into 3 rows with 2 muffins in each row. Or I can group them in a different way. I can make 2 rows with 3 muffins in each row. Right, you can also make 1 row with 6 muffins. You can find arrays in a ton of places. You could find them in a muffin tin, or an ice cube tray, a pack of soda, a checkerboard, a window pane, and on a phone. Arrays make counting easier, but how do arrays help you count? Sometimes counting things one by one can take a long time, but arrays arrange things into equal groups so you can count sets. Let's see. There are 2 rows of daffodils, and there are 4 daffodils in each row. You can write a number sentence to find the total number of daffodils. 4 plus 4 is equal to 8. There are 8 daffodils. It's faster to add doubles than to count each flower one by one. There are 3 rows of tulips, and there are 3 tulips in each row. We can add to find the total. 3 plus 3 plus 3. Let's see. 3 plus 3 is equal to 6, and 6 plus 3 is equal to 9. Arrays can also help you multiply. When you multiply, you put equal groups together to find the total. Multiplication is an operation, just like addition or subtraction. But how do arrays help you multiply? We need to pick up 12 eggs for Grandpop. How many eggs are in there, Moby? There are 2 rows, with 3 eggs in each row. You can multiply to find the total number of eggs. First, write the number of rows. That's 2. Then write the number of eggs that are in each row. That's 3. The X symbol means to multiply. This number sentence tells you that there are 2 sets of 3. So the answer is 6. There are 6 eggs in that carton. Nope, it really doesn't matter what order you multiply, Moby. An array of 2 rows with 3 in each row is the same as an array with 3 rows with 2 in each row. There are still 6 eggs. They're just organized in a different way. Grandpop wanted 12 eggs. We only have half a dozen eggs now. Let's see. There are 2 rows of 6 eggs. That means there are 2 sets of 6. So 2 times 6 is equal to 12. That's exactly how many eggs we need. See, Moby, arrays can make counting and adding a lot faster. But I'm not sure we made enough muffins for the bake sale. I think that's enough, Moby.
All right, thanks to our awesome friends, Moby and Anna, to give us a quick review on arrays and how it applies to multiplication. We're going to apply arrays today with larger multiplication number sentences, and we're going to continue to do some of the work that we did yesterday. More specifically, we're going to review a question from our independent practice. So, what is the basic idea behind multiplication? When two or more numbers are added over and over and over again, this results in a product. We call this repeated addition or skip counting. Mathematicians call numbers that are being multiplied together factors. Products are the answers. So in a number sentence, anytime you see those two or more numbers being multiplied, mathematicians call those factors. They call them, that's right, factors. After we multiply them together, the result, or the answer, is called a product. Is called a, that's right, product. When multiplying, the order does not matter because the product is the same. For example, if we multiplied 3 times 4, well, that's the same as 4 times 3. Just like in the video with Moby and Anna, they explain that each of these values are broken down into groups, that's right, groups. The reason that mathematicians thought it was best to organize things into groups because it makes it a lot easier to count. Do you remember last year in third grade when we talked about muffles and all of those delicious truffles? Just like the ones you see right here. We could easily count all of these truffles by ones, but that might take us longer than if we were to organize all of those delicious truffles into rows and columns. That's right, rows and columns. We can then break apart these rows and columns into countable size pieces, such as tens. We see arrays everywhere in real life. Can you think of where you see arrays in real life? One example that I was thinking of was an arena. Has anybody ever been to a sports event, maybe even a Phoenix Suns basketball game? When you go to the arena, you notice that all of the seats are organized into rows and columns. Maybe you've gone to the library recently. All of the books on the bookshelves are organized, that's right, in rows and columns. And even if you've been with your family at the grocery stores, you might have even noticed that all of those delicious veggies and fruits are also organized in rows and columns. We're going to use arrays today when we multiply some larger values. We're going to break apart those values into tens and ones. Even if we have numbers that are bigger, such as hundreds, we'll also break apart into hundreds. Make sure you have your scratch piece of paper ready to go. We're going to first review one of the questions yesterday from independent practice. Then we're going to do a couple more questions together. Get ready. Don't forget, all of your guided practice questions are below this video. Okay, let's go ahead and read question number 1. Again, This was on yesterday's independent practice, and this was a little spicy for some of our friends. So we're gonna go ahead and review this one together. Number one says, what is the product of 1,137 and 4? We just reviewed that product is the result of multiplying two or more numbers together. So we are going to multiply these two values. For question number one, let's go ahead and write 1,137 times 4. Let's review the strategy that we practiced yesterday where we break it apart into thousands, hundreds, tens, and ones. The first digit is a 1. This value is, that's right, 1,000. So our first number sentence is going to be 1,000 times 4. 1,000 times 4 equals 4,000. The next digit is also a 1, is 100. That's in the 100s place. So our next number sentence is 100 times 4 equals 400. Our next digit is a 3. That 3 is in the tens place. 3 tens is the same as 30. 30 times 4 equals 120. The last digit is a 7. 7's in the ones place. So our last number sentence is 7 times 4 equals 28. Remember, we call these partial products. We call these, that's right, partial products. Partial means to break up into pieces, and these are all of the products of the pieces of this number sentence. Our last step is to add all of the products. Reviewing what we learned in the first week on place value and stacking up all of our numbers to add or subtract, we're going to start in the ones place. 0, 1, 0, 1, 0, 1s plus 8 ones is 8 ones. 0, 10, 0, 10s, 2 10s plus 2 10s is 4 10s. 0 hundreds plus 4 hundreds plus 1 hundreds equals 5 hundreds. 4,000 plus no other thousand is 4,000. Our final product is 4,548. Amazing job to all those scholars who got that correct yesterday. Pat yourself on the back. Woo! All right, let's go ahead and type that in the blank space. Again, our product is 4,548. Nice work. Take a few seconds to organize your scrap piece of paper for question number 2. Let's read number 2 together. What is the value of 18 times 26? Since we know we're going to continue to multiply because it shows us a multiplication number sentence, go ahead and write that number sentence on your piece of paper now. Again, 18 times 26. Going back and thinking about what Moby and Anna said in the video about arrays, we know that multiplication sentences match the rows and the columns. That's right, rows and columns of an array. So if we were to build or draw a picture of an array, this array would have 18 columns or 18 rows, 26 rows, or 26 columns. Let's go ahead and draw a box on our scrap piece of paper to represent the array. It does not have to equal exactly 18 rows or 26 columns. Just make the box big enough to write your number sentences. As you can see, my array is pretty big enough so then that way I can go ahead and write inside of the array when I break apart these numbers. If I'm thinking of this side as 18 rows, well, we can again break apart the array into countable pieces. So one way is to break it apart into tens and ones. When we break apart 18 into tens and ones, well, 18 simply has 10 and 8. Let's go ahead and cut our array into two pieces or show the two rows. We're going to label the rows as 10 and 8. This means that this has 10 rows and this one has 8 rows. All together, it would make 18 rows. On the top, we want to label this as 26 columns. We're also going to break apart the columns into tens and ones that's right, tens and ones. Again, it doesn't have to be perfect. All we need to do is simply just break it up into two pieces. One of the columns is the tens, we're labeling that as 20, and the other columns we're labeling as the ones. Again, this is showing 20 columns and 6 ones. They may not be the same size, but that's okay. Since again, we know that arrays are multiplication where we just multiply the rows and the columns to find the number of squares on the inside, since we have broken apart the rows and columns into tens and ones, all we have to do is multiply the rows by their columns. The first row is 10, and the first column is 20. So for this array, that would be 10 times 20. Our rows are still 10, but our columns are 6. So our second number sentence is 10 times 6. At the bottom, we now have 8 rows. The 8 rows are still in the 20 columns. So the third number sentence is 8 times 20. The last number sentence is going to be our ones. 8 ones, 6 ones. 8 rows, 6 columns. So the last number sentence is 8 times 6. One really great way about using your array is that it allows you to remember to multiply the tens with the ones. Now what we need to do is just multiply each number sentence. 10 times 20 equals 200. 10 times 6 equals 60. 8 times 20 equals 160. 8 times 6 equals 48. Just like in our first example, all of these values are partial products. They are our partial products. All we have to do now is add all of these partial products together. I like to keep the rows and the columns together to make it easy and nice and organized. So I'm going to add 200 with 160. 200 plus 160 equals 360. Now I'm going to add 60 plus 48. 60 plus 48 equals 108. The last thing that we need to do is add all of these values together. 360 plus 108 equals 468. Let's go ahead and type in our answer into the blank space. 468. Nice job, scholars. Go ahead and read question number 3 to yourself. I'm going to go ahead and give you 2 minutes to set up your array. Again, use the example that we just did together where you break apart into tens and ones. 2 minutes, go to work. All right, welcome back. During that 2-minute study break, Kitty Badger jumped up on this table and prevented me from finishing these number sentences. So stick around after this example to see some of her shenanigans. All right, let's go ahead and review the setup for your array. Again, I didn't anticipate that in those 2 minutes you were to finish the number sentence. I just wanted you to set it up. So now let's go ahead and compare our arrays to see what's the same and what's different. Make sure you fix any errors along the way. Okay, we're multiplying 35 and 26. I chose to have 35 as my rows, so 30 and 5 were the tens and the ones. 26 was my columns. 20 and 6 were the tens and the ones in that number as well. My first number sentence in my first array in the top left would be 30 times 20. The second number sentence in my second array, which is the top right, would be 30 times 6. My third number sentence in the bottom left array would be 5 times 20. And my last number sentence in the bottom right array would be 5 times 6. How did you do? Amazing work. Now let's go ahead and find the partial products, then add all of the partial products together. 3 times 2 is 6. I'm going to include the 2 zeros at the end so that 30 times 20 equals 600. 3 times 6 equals 18. When I include the 0 at the end, 30 times 6 equals 180. 5 times 2 equals 10. When I include the 0 at the end, 5 times 20 equals 100. 5 times 6 equals 30. Our partial products are 600, 180, 130. Let's add the columns together. 600 plus 100 equals 700. 180 plus 30 equal 210. 700 plus 210 equal 910. The product of 35 times 26 is 910. Let's go ahead and type in our final answer. Amazing job today, scholars. Continue to use the array strategy on your independent practice today. Today, you're going to go ahead and have 4 questions. Use your scratch piece of paper to help you, and don't forget to click submit and then mark as done in Google Classroom. Happy Tuesday! You gotta do this number sentence. Do this number sentence. This one right here. Do this number sentence.